let's talk about reducing hum in vacuum tube radio receivers and audio amplifiers. So this is an All-American 5 design. This works for All-American 6 designs, and it'll also work for transformered sets. And what I'm about to show you here in a little bit will also aid you in reducing hum in your vacuum tube audio amplifiers. And it has to do with these capacitors. And I'll share that little trick with you in this video. It has to do with springs. So that's coming as well. First of all, this radio receiver was incredibly hummy. It was the hummiest receiver I think I've ever worked on, if you want to call it that. The thing was horrible. It even after it was recapped, it would sit, and it was to the point to where it was aggravating to sit in front of in a quiet setting. So something definitely had to be done about this. Now again, this was made by Moffett's. It said Moffett's on the bottom, so obviously Crosley maybe contracted some work out, something like that. And somebody else put this thing together, some other company, and whoever did it was probably, the hired help wasn't really taking too much care in wiring these receivers. So this one here from the factory would have been noisy. It would have just sat and hummed, and I'm sure it would have aggravated anybody that owned this. So in order for me to reduce the hum, I had to take a bunch of steps, and I'm going to show you these steps, and I'm going to also show you something else that should be done in a lot of these receivers, and they never really did this, just because they want to scrimp and save on costs in most of this stuff. And capacitors back in the day were expensive, especially these types of capacitors, because they're micas. So first of all, grab the schematic here. I'm going to, I don't know if I can knock down the, that helps out a little bit, doesn't it? Okay, so on the schematic here, you'll notice that in the main power supply section, we have 50 microfarads, and then we have 30, which is after this 1200 ohm resistor. So there's basically very little current at this point, and the reason that they want this high resistance value here, and a fair amount of microfarads, is to keep this line very, very quiet, because this runs to the plate of the preamplifier tube. And if there's any AC on the plate, it's just going to get very noisy. The power tube is not so, I guess you could say, incredibly sensitive to that, and that's the reason that we have that tied directly to the first 50. It's not getting that second bit of filtering here. It goes directly through the plate, or through the audio transformer, and then right up into the plate of the 50L6 tube. And I'll show you, there's a lot of ripple on this line, and it doesn't really matter with the 50L6 because, again, this is designed to drive a speaker. There isn't a whole lot of gain right here. Most of the gain that's being created is in that 12SQ7. Now, since this 12SQ7 does a lot of things, so basically they use these for AVC, they use them for detection, they use them for audio amplifiers, basically doing three functions. It's three tubes in one, I guess you could say. And because they want to scrimp and save on a lot of components in a radio receiver like this, what ends up happening is you get RF onto the grid of the 50L6. Now the 50L6, of course, will try and amplify that, but it can't do anything with it because it's fed into this big iron choke-like looking device to the RF, all right, called an audio transformer. So the audio transformer is not designed to amplify frequencies that are up at 455 kilohertz and whatever. So that creates an issue. This thing is going to try and amplify something that it really can't do. And not only that, it does create issues with us taking measurements in order to try and eliminate the hum. So the first thing that we're going to want to do is try and get rid of the RF on the grid of the 50L6. And I'll show you what I mean, because it's being carried through these sections here. All right, and this tube here is putting it right on the 50L6. So I'll go back to where I was here. Get that out of the way. I'm going to hook my oscilloscope up to the grid of the 50L6 tube here. So I'll find a convenient ground. I'm doing this while the radio is on, so let me do this. Let me do the dangerous stuff. Don't you do this. See the dial lights on here? Talk a little bit more about power supply filtering here in a moment as well. Okay, stay. Hopefully it'll stay without popping off, and I'll clip this on to here. Now this is on auto. I'll just put this on manual here so that it kind of locks it. Now as you can see, that is RF, and if I possibly, can I get a radio station on this? See, I'll turn this up a bit. I'll just tune into a station that I can somewhat hear and then turn the volume down. Just want this to receive something on the bench. Keep in mind that I have no external antenna on this thing right now, and I'm in the lab, and there is zip for reception in here right now. So it's picking up a noise here, so I'll just turn the volume down. So now you can see, because it's receiving something, that RF on the control grid gets really high. All right, so I'll tune it off frequency. And you see that come down. Okay. Now you can see that that's up really high. Now what we want to do is we want to put a capacitor from that grid to ground, to the ground in the radio receiver. We want a capacitance value that's high enough that it's not going to really disturb the audio quality. And we also want that capacitor to take away the RF. Okay, so we want the value high enough that it's only going to suck the RF off and take it to ground, act like a bypass capacitor, but we really don't want to affect the audio all that much. And now, since this is up at about 455 kilohertz and the impedance at this point is really high, we can get away with a capacitance value in the picofarads. If you look at this one here is 320 picofarad is what I have running from the grid. You can use that as a guideline if you're going to be working on All American 5 radio receivers and you get this kind of a mess on the grid, which I guarantee you will. So now I have this lead opened up right now. I don't have it attached. It's attached to ground, but it's not touching the grid. So what I'm going to do is I'm just going to push down on that capacitor with a tool here so the lead touches the grid, and that just popped off. So that it touches the grid, and we'll see what happens here. Okay, look at that, and that's with strong RF there. That's picking stuff up right now. So if I tune off frequency, you can see how that comes down. So I'm just trying to get onto a frequency that's picking something up so it really shoots the RF through there. So if I touch this onto here, you can see that cleans it right up. And then if I tune off frequency, you can see that it's just pretty much the 60 cycle hum that's coming through there right now. Again, if I let this off, look what happens. Very hard to work with this if you want to reduce hum. So you definitely want to get the RF off the grid of the 50L6. And this applies to all sorts of different types of vacuum tubes as well. It applies if you have a 6V6 output or a 25L6 or whatever you have in a receiver like this. Always check the area after the detector tube and make sure that there is very minimal amount of RF on the grid of that tube, and that'll allow you to work with this section and really narrow the hum down. So this is what we're dealing with hum right now, and that's actually very low. It's almost not audible in the receiver, audible in the speaker of the receiver right now, compared to what it was before I moved all the grounds around and added another filter capacitor. It was up around 250. Okay, so that's just ridiculous, an immense amount of hum here. In the previous clip, I added a capacitor from ground to the control grid of the 50L6 tube, and what that's doing is that's taking the RF off of the control grid of the 50L6 tube and basically taking it to ground so that we can better see the audio signal. Now, if we don't have this capacitor here, it's very hard to whittle away at the hum in this radio receiver because we're looking at two signals on the screen at once. If you recall, it was a big fuzzy signal on here. That's because this is displaying RF and audio at the same time. So we want to get rid of the RF completely, which is very easy to do with this capacitor here. This capacitor, the value of the capacitor, looks like more of a short at RF frequencies than it does at audio frequencies, and that's the reason that it's not affecting the audio very much, but it is affecting the RF that's present at the control grid. So that's the reason that we add that capacitor there. So it's just basically affecting the RF, pulling it to ground. It affects the audio just a touch, but nothing that the tone control can't compensate for. This tone control has an incredibly wide range. So now that we've pulled the RF off of the control grid, I can look at the control grid and slowly whittle away at the hum by moving components around, adding filtering, and I created a star ground in here. Now I would display that whittling away process, but that would be about 6 hours of video. That took me about 6 hours to move all the wiring around and to move parts where they needed to be to really get this radio as quiet as it should be. So 6 hours of video and me moving components around is probably not too incredibly desirable, but that's the amount of time it took me on my end just to lower the hum. And that's excluding all the other problems in this radio receiver. Now, I don't want to surprise you. Most of these older radio receivers have had technicians in them at some point in time. And a lot of these technicians, they don't know what they're doing. They're tying things in, twisting wires and taping them and doing all sorts. I've seen it all. So whenever you get an older radio receiver like this, whether it's an All-American 5, All-American 6 transformer set, even amplifiers, whatever that's older, the older the device is, the more chances of hands that have been inexperienced have been in here and they've moved components around and done things that are very wrong. Now, this was a combination of both of that, I think. It was, the combination, both of those things, I should say. It was a combination of bad design to begin with, and then, of course, technicians getting in here, like you saw that capacitor replaced and stuff, and just people hacking things up over time, maybe even moving wires around. It was probably done at such a long time ago that I wouldn't know the difference between it and the factory wiring. So one of the major things to get rid of hum in a radio like this, we've eliminated RF so we can look at the hum over here now. Now, in order to lower the hum is to play with the capacitance value, the filter values in the actual rectification area. Now, a lot of people will frown upon this. They'll go, oh, you can't add more capacitance than what's stock. And that is just speaking through inexperience. And I see this all the time. I see this in forums and all that kind of stuff. Somebody will add 10 microfarad to a capacitor, and it's just a big flurry of comments because of this. I'm going to tell you the facts about this. So what's happening here is we have half-wave rectification. So, a full wave is like this, right? So we're only utilizing half the wave. So there's a big gap between the bumps and the filter capacitor. The low values that they had way back in the day have to fill those gaps up in order to keep the DC nice and clean. If not, we get a ripple at the top. And this is the advantage of full wave rectification, is because the bump that's on the bottom portion of the cycle gets put up to the top, and you get double the amount of bumps with full wave. And of course, you get 120 cycle hum. That's where you get that 120 cycle buzz or hum from, is because full wave rectification takes the bottom half and folds it on the top. Basically is what it's doing, is putting it on the top. So in this case, we only have one diode here. So we have a bump, a big space, a bump, a big space, a bump, and that's what it looks like for half wave rectification, instead of a bump, a little space, a bump, a bump, a bump, a bump, a bump, like that, right? Since we only have half-wave rectification, lower capacitance means that this capacitor has to hold up that area. So, and much of the time it won't do that, and that's very easily seen if we look at this. Now, in this case here, I'll just turn this down, just bump this up here. So, in this case here, you'll see that there's 50 microfarad here, and then we have 30 over here. So a total of 80, but it's not really 80 at this point. You can't look at it like that because this is really current limited by this 1200 ohm resistor over here. So this one here is almost right at the rectifier's cathode through a 47 ohm resistor. And then this one here, of course, the current is limited because of the 1200 ohm resistor. And then this line is going to have a lot less hum on it because of this resistor right here. So this is filtered a lot better over here, and of course that feeds the screen of the 50L6 and everything down the chain. So this is important to have lower hum here, because if this tube here gets a lot of hum, it's going to amplify it, and we're going to get a very noisy radio. Okay? So 30 over here has been changed to 47 in here. Okay, so there's 47 mics, and this is what I'm using in this radio. Now, 50 over here has been changed to near 100. I've done lots of experimentation with the rectifiers in these tubes, and I've never taken a cathode bonding wire off. I've tried 250 microfarad, and in one case I did experimentation with 470 at this point, and I never took a bonding wire off. The only thing that excessive capacitance of values way up there is going to do is going to take out the dial light. So what ends up happening here on this schematic here, what ends up happening is the more capacitance you add here, if you shut the radio off, okay, and then immediately turn it back on again. If you shut the radio off, these capacitors get drained immediately. So this 50 is going to go down and the 30 is going to go down. But the cathodes and all the vacuum tubes are still warm, so they're still into emission. So what happens is if you turn it off and turn it back on again, when you turn it off, the caps get drained completely. Okay, and when you turn it back on again, now the rectifier has to charge these caps and feed current to all of these tubes all at one time. And because you do that, you see the actual current being drawn by the flash of the dial light. Now, if I was to say, take this up to 200 microfarad, I'd probably burn that dial light out. I'm at 100 here and I get a bit of a flash, and that's for this radio receiver here in the circuit, it's going to be absolutely fine. I've done radio receivers like this with 100 mics after a current limiting resistor here, small one, and I've never had an issue once. Now, this is speaking through experience, not repeating what other people are saying all the time. People say, oh, you can't up this at all. It has to be right at the factory value. Whereas you can look at another radio, and that'll be 80 microfarad. In another radio, almost the same circuit. Okay, so another thing that tells you that you can get away with that is much of the time older capacitors that would say 50 can be positive 100% in value. So this could be 100 microfarad. That's double. That's double what it is. It's another 50 microfarad right on top of that. And this is very common with old capacitors. They have very wide ratings for their capacitor. As you saw with the yellow capacitor there, the ratings for that capacitor are much, much higher, even though the leakage is higher as well. They're much, much higher. So just depending on the manufacturer of the capacitor and everything, you can move around these values a little bit and not really worry about it. You don't go crazy with the values, or you're going to start damaging the 35Z5's cathode. You might cause cathode stripping, or you might even burn out your dial light. So I found that 100 here and 47 here is absolutely fine to get a bit of a flash with the bulb. You will get a flash with the bulb any way you look at it. Even if the capacitance values are factory, it'll flash if you turn it on and turn it off again. So what I'll do is I'll shut this off and I'll give you an example. So I'll shut it off, turn it on. See that flash? All right. Now in the camera, it looks a lot brighter than it actually is. It's not a big deal. That's a little bit of a flash. That's nothing that's going to take the cathode out or burn out this 47 dial light. Okay. In fact, I'm a long ways away from it. I'd probably have to double this to take that dial light out. So just a word. I know a lot of people, there's so much misinformation going around about this. I'm going to tell you something I've done with a Hammerland. I have a Hammerland HQ129X. I have brand new capacitors, so the leakage of those capacitors is very low. Very good capacitors. Nishigon type capacitors, Rubicon. I have all sorts of different types. On the cathode of the rectifier tube, which is a directly heated rectifier tube in that radio, I have 475, I think it worked out to be total microfarad on the cathode of the rectifier tube, a directly heated rectifier tube. That radio has been in service for 12 years now, and the tube is still the same. So there you go. So I just want to broaden the horizons on filtering capacitor here. The values of the filter capacitors in the rectification section of these radios is not specific. Don't go lower than the values that they've specified, but you can definitely up those values safely, marginally, as I said here. Okay, so this is, in my radio here, this is now just about 100, and this is 47. And that alone bumped the ripple down like you would not believe in this receiver. It sits here almost quiet. I can sit here right now, and I can barely hear it. I can barely hear it. So what I'm going to do is I'll just turn this back up again. Now, when you're looking at the cathode, or let's say the plate. Okay, we'll go right over to the plate here of the 50L6 tube. If we're going to look at the plate, you're going to see a lot of ripple there because we only have, even with 100 microfarad capacitance on this area right here, we're going to have a lot of ripple there. The reason the hum is so low, even though we have a lot of ripple on the plate of the 50L6, is because there isn't a whole lot of amplification happening here. This tube is designed to drive a power tube. It's designed to drive an audio transformer, which is designed to basically transform the impedance down to what a speaker is. So we're taking the high plate impedance of the 50L6 and turning it into an impedance that the speaker wants to see. So this is just a power stage. This is where the amplification happens, and it's important to make sure that the ripple on the plate of this is low, and it'll be in the 100 and some odd millivolt ripple range somewhere. This will be a couple of volts, as I'll show you. And this is normal. So if you're going to look inside a radio receiver, I'll tie to the plate here. The plate should be number 3. Okay. That's the ripple, 2.43 volts RMS. That's what the ripple looks like on the plate right here. That's through the audio transformer and on the plate of the 50L6. That is normal in an All-American 5 or All-American 6 style receiver. If you have a receiver that's a higher quality AA5, AA6, something like, not really All-American 5, All-American 6 design, but it is a small compact design like this, like the FADA that I went through. You can look at my YouTube videos on the FADA. That is a very good design, and they actually spent the money and put a filter reactor in the radio in that FADA. So the ripple is going to be a lot lower, and consequently with lower capacitance values. Now, since we have a reactor basically reacting with the AC, we have a much lower values, or a much lower value of hum with a much lower value of capacitor. So these are the two capacitors here on this side. So there's a 47 and a 47. The reason this one is smaller, it's a 250 volt rated cap. The reason it's smaller is because it has to fit in this small area. That's the only reason I didn't put another one of these here. So this is well overrated, 250 volts, and these are 450s. So 47, 47, 47. And this is what I end up with on the plate. Now, if I remove this, this will go up to about 5 volts AC, and then it starts to get a little audible in the speaker. So that definitely helped things out. Again, don't be scared to add a bit of filter and capacitance. Just don't go crazy with it, okay? Don't let what all of the old techs are scaring everybody about and going, oh, you can't do that. Don't let that affect you. The logic is you can definitely add capacitance, okay? So let's take a look at the B plus line here, the one after that, so the second filter here. Let's see what it's at. I can get this on here. I can. Look at that, so low. So 130 millivolts, something like that. So if I go to here and go down here. So there you go, 130 millivolts, right? The reason it's moving, bouncing around like that is because the actual AC is moving around because my soldering iron is on. And of course the trigger is somewhere else. So don't worry about that right now. So anyways, we'll go back up to the other setting. Right about there, it'd be fine. So there you go. So that is one technique in getting rid of the bulk of half wave rectification hum. Now, if we were to say, look at the control grid here of this tube. I've got the capacitor attached again. See if I can get this to clip on here and cooperate. Doesn't want to clip on there. Maybe I can clip on the top of the cap. Pull the sleeve back a little bit, clip on the control grid. There we go. Okay, so let's do this. This get to where it should be. So there we are, and I'll go to AC coupling because as soon as I hit that, it goes back to DC coupling again. So we have about 26 millivolts there right now. I think it should be a little higher. There we go, right about there. 40 millivolts, wasn't making good connection. So that's about the level of the AC hum that is in here right now. Now you can see if I put my hand on this capacitor, just let it stabilize there. Look at, and that's about where it was in the beginning. I don't know if you can hear that, but it's humming pretty good. I'm going to get the mic closer to the speaker here in a moment. I'm going to show you another technique to get rid of hum. And this one's kind of tricky. Now, there's a way to solve that problem in many cases in a lot of audio amplifiers is you can actually take a capacitor like this. Well, let's take this one here first. This is the capacitor. It's an Illinois capacitor right here. And you can put a spring over top of it. This spring is just a little bit larger than the diameter. I have a universal spring kit. And these solder beautifully. And what you can do is you just basically unwind the spring a bit so that you're kind of putting tension on it, slip the cap in, let the spring go, and it tightens onto the case. And you have a perfectly shielded capacitor. And what you can do is you can add a ground off to some place if this is picking up hum still, even though the outside foil is on the outside. So depending on, like you can see here, let's see, if I started, the outside foil end is attached to this end. You see a little dot there? So if I put my finger here, okay, so you can see there's a little bit of hum there, but as I get closer towards the grid, I'll slide my finger across this capacitor. As I get closer to that lead, you can see how much the outside foil is actually shielding me. If I had this reversed, that would be 200 millivolts right now. So the volume control is bottomed out right now. So this outside foil is pulled to ground, and that's why it's virtually not seeing me. Whereas if I come over here, just me sliding my finger across it, so I'm getting close to that lead. And there is one example of the importance of the outside foil. Now, if you have this in the correct orientation and you slip a spring over top of it, you can add another ground to this to completely shield this, and that works very good. If you need to shield the whole thing, slip the capacitor right into the center of the spring, put shielding over and leave the spring longer. It works very, very well. And in some cases, if you want to balance hum, if you find an AC source, go from end to end with a variable potentiometer, so a potentiometer from end to end of the AC source, and tie the wiper to the shield and move this around. And a lot of the times, you'll even be able to take the hum down more. And I'm going to get more into that technique in the future here. That's one of the techniques I used to locate and narrow down the hum in this with this actual particular capacitor right here. So very, very important steps to do. So we have about 40 millivolts of hum, and that's as low as it's going to get. If I shield this capacitor right now, it might go to 39. Okay, that's about it. So it's not going to be noticeable. So what I'm going to do now is I'm going to move the mic close to the speaker, and I'm going to show you another capacitor that you can eliminate. Not add, but you can eliminate in this design to get rid of a lot of hum. In many radio receivers, in audio amplifiers, you'll notice an audio output stage that looks like this here. This is a Class A audio output stage. And what they've done to establish bias for the 50L6 is they've lifted it above ground by 150 ohms. Now, by using this biasing scheme, what ends up happening is we don't have a good path for AC anymore to ground, so there isn't a very good path right here. Now, this works great for biasing, but in order to get that path, we want to add a capacitor because, again, as mentioned before, capacitors pass AC. So you'll notice that a lot of these output stages have a cathode bypass capacitor, which is usually between 10 and 30 microfarad or something like that. Now you can see that they've added 10 microfarad across this here. Now when you add that, it appears to give the amplifier just a little bit more gain, so it picks the volume up just a little bit, and of course it's going to enhance the bottom end because of course we have a path for that AC now. It doesn't have to travel through 150 ohms. It has more of a direct path because the capacitor looks like more of a dead short to that AC, just like that other capacitor that we added to eliminate the RF. That 320 picofarad capacitor looks like a short to the RF frequencies, but not to the audio frequencies. Okay, so now since this capacitor is in here, it's going to want to enhance the bottom end frequencies a little more, and it's also going to appear to give us a little bit more gain. Now, since we're not really worried about bottom end frequencies here, because the core size of this audio transformer is so small, we're not going to get down into the bottom end anyways. Now, there's enough volume or audio gain in this circuit that we don't need the little bit of extra gain that appears when we add that. I can basically destroy the speaker if I turn the volume control completely up without this capacitor in circuit. So the capacitor itself is basically just there to give that touch of gain and to enhance the bottom end, which in many All American 5 radios, you won't see this because of hum issues. Now in this, they've added this, again, which kind of goes to show me a little bit of inexperience in the design engineer that put this together. Now what I'm going to do is I'm going to get the microphone. I'm going to position the microphone right beside the speaker, and what I'm going to do is, I'm not sure if you're going to see this, but what I'm going to do is I'm going to touch this capacitor to the cathode, and I'm going to remove it. And I'll show you the difference in the hum by taking this capacitor out of circuit. Removing this capacitor is a very, very big, I guess you could say, improvement to this radio receiver. So actually removing parts in this case is a better situation. So I'll get that all set up and I'll be right back. I have the microphone close to the speaker, so the hum will seem just a little bit worse than it is. But to give you an idea, I'm about 2 feet back right now, and I can just barely hear the hum. So what I'm going to do now is I'm going to attach this capacitor in circuit. I'll just touch it and it'll push it into circuit here, and you can hear the difference between no capacitor and adding this capacitor. So right now there is no capacitor, and I'll just let you listen to that. And now I'll add the capacitor. No capacitor. Added capacitor. So you can see in this situation, getting rid of that capacitor is definitely beneficial. Let's restring a dial string together, and I'll show you a few tips and tricks to make this just a little bit easier, because we all know that dial strings are a big pain. Now, first of all, the first thing that you want to do is get a decent dial cord, and a decent dial cord for this application is nothing special. Go get yourself some 40-pound fishing line. It's pretty much the exact same stuff, okay? So this is the kind of stuff that you're going to want to get. And the thickness is a nice medium for most dial cords. So I would say that, you have some really thick ones, you have some really thin ones. This is a really good medium, and it seems to work everywhere. So this is the stuff right here that I use. Now, the first thing you want to do before you start using this stuff and before you actually start going is get a few tools together. So get a nice sharp pair of clippers together. That's very important. Get yourself some tweezers, some really nice tweezers with a nice point on it, because these will be very beneficial. You're going to want to get some super glue. Have that handy. All right, this is the stuff that I prefer. I can get this stuff locally, and when they say super, this stuff is crazy. It's just absolutely super. So that stuff sticks like you wouldn't believe. So the first thing you want to do before you even start doing anything so that you don't forget is, you can see the end of the line here has been cut, but nothing's been done to it. So what you want to do is take a hot soldering iron like so, and you just want to touch the end of that like so on the, you don't need to use the tip, just if you do use the tip, you'll have to clean it. But just touch the line like so, and that way you melt the end of it together so that it doesn't fray. That is a real pain if that starts happening. You're working on this and it starts to open up. You won't get it through the small holes and things in the pulley, things like that. So now that this is done, we'll just put this aside for a second, and I'll talk a little bit about what needs to be done to the radio in preparation first. So the very first thing that you should do is make sure that the tuning capacitor moves freely. If it doesn't, clean the ball bearing in the front. I use WD-40. It works very, very well. And you also want to clean this area because the grease over time solidifies that they use. And in the back, there's a little ball that sets the tension, and there's a set screw on the back side here. See that little set screw? And then there's a nut to make sure that that screw doesn't move in the center. What that does is that pushes this whole mechanism forward so that the plates inside the variable capacitor don't touch. So as you drive that screw in, what it's going to do is it's going to move this rotor, it's going to move it forward. So now you have to find a nice center point if you undo this to try and free things up. You're going to have to find the center point. So what I'm trying to say is the plates, they kind of, I guess you could say they mesh like this, okay? So they're going to go in like this, and they're not going to touch each other. They're just going to move in and out. So if you don't have that set right, these are going to sit like this, and they're going to rub here. Or if you have it too tight, they're going to rub here. So you want to get it right in the center. So sometimes that takes a little bit of fiddling if you undo this on the back side. And a lot of the times you can just find out with an ohm meter. So you can put an ohm meter across the rotor and the stator, and you can fully gang this, and then you can have this, or fully meshed, I should say, have it fully meshed, and then have this open like so. So when it's fully meshed, if you feel any rubbing, you know that it's shorting. Now, if you want to find out if it's actually shorting, if you have everything set right, is just put an ohm meter with a beeper on it and very slowly move through the travel of the entire capacitor. And if it goes beep and then stops, and it goes beep in another place, you know that it's either touching on either side, so you'll have to adjust the tension. Now, you'll notice here on each side that these are bent out, and this is to create dial tracking in this radio receiver. That's the reason they have the cuts and the plates like that, so that you can actually bend these out and make the dial track correctly with what's, or the capacitor and the oscillator track correctly with what's on the dial. And as you can see, this needed to be moved quite a ways to make this track. And a lot of that has to do with this coil here, the oscillator coil's Q changing over time. Remember, this thing's been on here since 1947. Things have dried out. This thing has, been sitting, on top of, basically hell's oven here. And everything on this thing is just super dry. So chances are the varnish and everything has changed and things have shrunk. And of course, the inductance and the Q may have moved just a little bit. So you have to adjust these over time. There's a trick with this capacitor too that a lot of people don't know about, and that a lot of people don't know about in a lot of radio receivers. They only show an adjustment for the oscillator on one side. Now, if the thing tracks horribly, even though you've adjusted this oscillator, you need to go to the other side, and they've hidden one down in here. And it's not labeled on the schematic. I'll show you this here in a little bit. All right. They've hidden one. If I can get the light down in there. Let's see if I can make this happen. They've hidden one. You see that? Right there. And that will need to be adjusted as well. And of course, with this radio, everything that could go wrong has gone wrong. This was supposed to be 1 day, and this radio took 3 days in order to make things happen with this. So this one here was abnormally stubborn. Anyways, once you get the capacitor moving freely, all right, so this is moving freely, you're doing good. If you remove a pulley like this, you want to make sure that when you bring the pulley back, that screw is in line with that hole. You also want to make sure that the backlash is taken care of with this spring. This is very easy to do to set the backlash. Basically, you set it about 1 or 2 teeth, depending on the amount of resistance you want on that. And so what you do is you would put the spring in here. You got to be careful when you remove this pulley if you do, because this spring is going to take off on you. Put your finger on it. Sometimes it's good to wear eye protection depending on the strength of the spring. This is good practice anyways. What you want to do is you want to make sure that the actual spring is taken care of. What you do is you bring this to where you're going to put the pulley back on. So in my case, it was this side here. So I had basically the spring in here. It's loose at this point. You take the rear of the gear, you pull it about 2 teeth, put your fingernail in it, and then when you have it, move this to the place to where it's supposed to be and pop it back in. Now, in this case, this one kind of comes in on an angle, so you have to put this off a ways, and then as you push this back into place, this moves around and then engages with the gear. So if you remove this, you're going to have a bit of fun doing that, but just keep your fingernail in there or whatever, and that'll keep the tension on the spring. If you're worried about it, you can put a little piece of tape over top of it, and that'll usually catch it and stop it from going away. Now, that's only necessary if you take this whole mechanism off, or if somebody before you has taken the mechanism off, you really don't need to worry about that. So as you can see, this moves real free now. And just the slightest amount of resistance will cause the dial cord on this not to work. It's very, very picky, this one here. Just because it has a gear reduction unit, there's a bit of, you can feel that there's a, because it has to drive gear and there's a, some backlash taken care of here. It's not as free as a lot of these capacitors are. They almost float. This one here, there's a bit of resistance, even though that there is the smaller gear on this one and the larger one over here, which is getting into ratios, and we don't need to do that here. So Once you have this all cleaned up and working well, what you want to do is you want to lubricate this as well. Make sure that you do not get any oil on the little pulley surface here, so that you can see it's got a bevel on each side. You also want to pre-lubricate these small pulleys. Make sure that you do not get oil in here or on this at all, because the dial string has to ride over this and go over this pulley and down here. So if you get any oil on it, it's going to slip. So you want to make sure that this is lubricated, this one and this one. If you get oil on any of these, just wipe it off, dry it off the best you can. You just want oil underneath it so that it travels correctly. That's it. And of course you want to add some here. You can move this in and out a little bit and move it around and turn it and just get the oil moving through there. A lot of the times you don't need to take these off because it's just fine. Just add some oil. This is as smooth as glass. Now you'll notice a lot of radios have a tuning shaft that does not have this bevel here. It's just a long shaft, and that's absolutely fine for many radios because they have a really large pulley on the front of the tuning condenser, and they don't have this very close to the actual shaft. This is so close to this shaft that the dial string cannot travel along the shaft, and that's the reason they've put a bevel here to keep the dial string centered. It can only move just a little bit along here. Now, there's an upside and a downside to this. First of all, the fact that it can't travel will want the actual dial cord on here to jump over itself in some cases if the dial cord isn't very good. So you got to be very careful, and that's why I suggest, don't cheap out on the fishing line. Get a good nylon fishing line like I just showed you, and that'll eliminate that. Now, when you first start to, go through this and clean everything up, you'll notice that a lot of the times that this little beveled area will have a really nice polish to it. Get rid of the polish. Take some 500 grit and go over this and just rough it up just a little bit. So basically what I do is I'll take a piece of 500 grit paper, hold it on here, and then just rotate this. And then once I've taken the grit off, then what I do is I go back and forth like this, so that I'm putting the scores back and forth. I don't want the scores traveling with the dial cord. I want the scores going this way. And then that way you'll get just a little bit more friction on this pulley right here. So once all that's done and the thing is pretty much ready to put a dial string on, this is everything I'm telling you here is valid for all receivers that have dial strings. Okay, so you want to definitely prepare all of this before you do the dial string. Now, you'll see here that they have a little fold where the spring is, and the fold goes over towards the hole. So I'll just back this up here to the fully meshed position. So you can see this here, the fold goes over this. That tells us that this spring is not going to be pulling this way. Now, you'll notice that if the spring goes towards the little hole in the pulley here, it's pulling towards where they've crimped it over. That's not the way it works. What happens in here is to set this up, you'll have this pulled this way, but in the end, what we're going to do is pop the spring over this way, and that way the spring tension is this way. It's 90 degrees to where they've crimped it over. You wouldn't want to leave that there because over time it'll probably pull that open and the spring will pop out. And now that makes tensioning of the dial cord on this radio all that much easier. Take your dial cord, and what you can do is you can pre-size it if you want. So tie a knot in here and then take your dial cord and run it around a few times and then go, okay, I need 2 or 3 feet. Or if you want, just cut yourself 4 or 5 feet and then deal with the waste in the end. A lot of people, they want to, I guess you could say scrimp and save as much dial cord as possible. This stuff is cheap and it's not worth the hassle to have this thing in your hand while you're doing this. So I know that this one here is going to be about 3 feet. So I'm just going to pull off 3 feet of this right now and just discard the rest. Probably more like 2 and a bit feet, but whatever. Now that I have that end on here again, because I've just cut it with my sharp cutters, what I want to do is I want to take my soldering iron again, and I just want to touch this. Don't need to use the tip. You're going to get this nylon on your tip. Just touch it there like so, so that way this doesn't fray. That is an incredible pain. So the first thing I want to do is put my cord through the little hole in the pulley there. See that? So I'm going to take the cord, put it through the hole in the pulley, and put it right through this loop here. And then I'm just going to form a knot. So I'll get this over here like so. I don't need the tweezers yet. Okay. Now that I have a knot in there like so, you don't need to be very particular with that knot. Just have the knot in there like this. Now this stuff is really slippery, And what's going to happen is that knot is going to come undone. So what you want to do is take your super glue. Don't leave it till the end, because if you leave it to the end, that's going to come off and you're going to lose your spring tension. So what you want to do is just take just the slightest dot of super glue and put it on there, and that'll stop it from unwinding while you're working. Let's move that out of the way again. So now I can cut the axis off here so this doesn't get in my way, like so. And again, I'm just going to touch that with my soldering iron, and that way that end won't fray, just like so. So now I'm going to pre-tension this right about to the hole, okay? So it'll be pulled out to about here. Again, in the end, we'll pop the spring over. So I want to make sure that this is fully ganged at this point, or fully meshed, I should say. So, and then what I want to do is I want to take this up to this beveled area here on the pulley, and I want to go onto here and go 1 and 2. One loop isn't enough. You won't get enough traction in a case like this, so you want to put a little bit more than one loop on there. Okay, and then what I'm going to do is take this, put it into this pulley here, run it over to this pulley here. Okay, so what I'm going to do is put my finger on here right now. I'm going to take this down here like so. I'm going to put this over top, so it's in this pulley here. Now, I wouldn't want to go on this side, because obviously if I went on this side, because this dial string is here, it's just going to loosen off. So whenever you have a dial string entering on this side, you want the other one entering on that side. Okay. So now I can't just go to here like so and then pull it in, because obviously I'm going to only get basically half a turn here, and it's going to bind up, so I'll only get a little bit. So what I want to do is I want to run this around like so. Now here's the trick that will catch everyone. If you go here, so I just want to hold this tight right now. You can see I've let the tension off. I'll adjust that in a moment. Now that I've done this, what you want to do, so you can see how I've got the string here. You can see how this piece of string is up here like so. If I was to put that string in the hole like this, this would bind up. All right, it would try and tie a knot in itself. So what I want to do is I want to take that string and push it down, just like so. Okay, so you see that there? Hopefully that's in focus. I want to take that string and push it down on the pulley like that, and then I want to take this string and I'm going to put it in through the upper side of the hole. Okay, if I put it in the center of the hole, I'll get halfway and it's going to want to do this. So I need to get it into that portion right there. So I'll put this back down so I can work on this. Now what I'm going to do is I'm going to get the tension on this again. So that's pretty easy. I'm just going to pull on the dial string here, and I'm just going to do this. Okay, so you can see that. I've got some tension on it. That knot's just about to there. Okay, so now what I'm going to do again is go around like so. I'm going to put my finger here to hold this so this doesn't back off. I'm going to grab that piece of string. I'm going to move this out of the way, just like this. And now I'm going to put that over top. Okay, I'll just get this over here. Now, if it pops out or something, you can always just redo it. Not a big deal. So I'm going to try and put this through the top side. There it is. Okay. So I have that through there. Now you're going to take your tweezers, because it's going to make life that much easier, and you're just going to pull that tight. Now what I'm going to do is, a lot of these pulleys, I'll just pull tension on this for a second. A lot of these pulleys here, they have another little hook on the other side for you to put the other end of the dial string in, so you can pull it tight and then pull the string or pull the spring tight later. You can see on this side, or on this actual pulley here, there is nothing except this spring. So both ends of the dial cord go through the loop of that spring. So again, what I'm going to do is just put my finger here to hold the string tight so I don't lose tension. And what I'm going to do is just poke this through the hole here, like this. Should go this way. I'm going to get that through there. I get my tweezers, get in here like so, without hooking the spring. There we go. So now that I have this here, what I want to do is I want to put this through here like so, so I can get myself my other knot. I'll grab this here, and I'm just going to pull that nice and tight. like that right there. Now, what I'm going to do before I do anything again is I can let off. Okay, as you can see, it's holding the tension now. Now what I'm going to do again is I'm going to put a little dot of super glue on there. It turned out to be a little bit more than a little dot, but that's okay. And then I'm going to cut this off like so. Make sure that you don't get any super glue on your soldering iron, because if you get super glue on your soldering iron, the fumes from it will really bother your eyes. So now that that's done and that's set like that, there's quite a bit of super glue on there that came out like so. We'll just run that around. Now that this is done, what I'm going to do is take the spring and I'm going to pop it over the other side of the pulley, just like so. And as you can see now, this is on a 90 to that, and the tension is set. And if I go back over here and I move the dial, look at that. No problems. And it moves just as it should. So now that that's done, what we want to do is we can, at this point, you could put the dial face back on and the pointer. So I'll just grab the pointer and show you how the pointer works here. So this is just a pointer. I'll put it on without the dial face. So this is the pointer here. Now, in order to get the string into the first little area here, you can put the dial pointer on a bit of an angle. I'll just zoom on into this to make this a little bit easier to see. Okay, so you can see how there's a little hook on the bottom, a hook on the top, and a hook on the bottom. So what you want to do is you want to put this through here like so. Okay? Actually, it's the other way. It goes like so. Goes through like so. So it goes through the hook on the bottom first. And you can see it now, it's going over the top hook. And then, now what we can do is give it a bit of tension and pop it over the edge, and now it's going under. So it kind of goes up and over like so. Now you'll notice that this will slide along the dial cord relatively free at this point, and there is enough friction that it isn't going to move on its own. It will travel along here, no problems. Nothing will stop that. Now you'll notice that this is at the end of its throw. The capacitor is fully meshed. Okay, right there is at the end, but now I'm kind of sitting mid-dial. So to preset this, you can do this with the dial face on. I don't have the dial face on right now, and I don't want to put it on because the paint is very, very tender on this. So I'll just show you with this off. So you can see some of it, it was like this before, but some of it has flaked off. And I'll talk about how to stop this from continuing, because what happens is one little piece will lift and it'll take an entire chunk of the dial off. So I'll show you how to stop that here in a moment, okay? So now as you can see, you can line this up. You know, the dial pointer's here. You can line this up. You can see that, you know, it's at the end of its stop. So the dial should stop at the last line and at the last line, or even right at the very edge, okay? Now this varies between different radios. So what I want to do is I want to slide this over. So we'll say right about there, okay? Now what I want to do is I want to take this and move this along. And as you can see, if I line those up again, it can go just a little bit this way. Like so. We'll go back to this end. Let's get my fingers out of the way. And it's still passing just a little bit, so back this up just a tad. And I think that's a little more than a tad. It might be because I'm looking at this camera on an angle as well. So just a little bit over, like so. And then we'll go over here, and we'll try it one more time. We'll just get this out of the way so it's not rubbing on the bottom. And put that over here. And as you can see, that's pretty much spot on. I'll put that right on there. I don't know if you can see that in the camera. Spot on, right to the end there. And that'll preset the dial. So now if you want, you can pop this over like so, and then put this on, and then drop this back in, and everything will be fine at that point. And then now you're ready to actually do the RF alignment. Until you do this, you can't do any alignment. Okay, that's absolutely important. And that's pretty much it. Once you have everything all set up, you can put a little dot of super glue on here, or if you want the ability down the road to move this again, use a little bit of nail polish or lacquer, and just put a little bit of nail polish or lacquer on the top. Really, at this point, there's enough tension with the dial string in here that this isn't going to move on here. You can smear just a touch of grease on here, just some very, very light grease, and then that way you won't get that kind of a rubbing noise. It really smooths that up if you're wanting to do that. Now keep in mind that grease attracts dust over time, and dust will get into that grease. So you got to keep that in mind as well. So it's kind of a balance. We know that this thing is pretty much sealed up. Okay, and the dial, the actual little dial plastic comes over. So I would say grease in a situation like this would be okay. Now I'm not going to apply in here because I still got to work on this. I'm going to show you some other things on this radio, and I don't want to get grease all over my hands. But that's how it works out right there. So you can see the dial string. See how it rides forward on the pulley and it'll just bump back? See that? And it kind of keeps it all centered. And there's good tension on that as well. So that worked out very, very well. And that's how you do a dial string on a radio receiver like this. Again, this isn't normal. Having the spring pop over the actual shaft of the pulley is not a normal situation. A lot of the times they have another hook like this on the other side. So you would start at the other side, and then you would do the dial string and work your way towards the spring. And then what you would do is you would have the dial string pulled taut, and then you would tie the spring close to the hole, and then you would stretch it onto the little hook, because the hook would actually be the other way in most of the other pulleys. So a little different than normal, but it still works fine. In fact, I like this because you can just pretty much have a very little preload on this and then just pop the spring over and everything is perfect. It works well. And that dial string should be good for a very, very long time. This is great dial string, great fishing line. And it's, since it's, 40 pounds, it'll ride on these pulleys for years and years to come. And there are no knots like that was in the original situation. Somebody had tied knots that had to have bound up on these little pulleys. The knots were shown in the video on YouTube. So they had to bind up on here. Maybe a knot would bump over this or something. I don't know what they were doing. So this thing was just so messed up. It wasn't funny. It's just the tip of the iceberg. There's so many things I could tell you about this. So anyways, dial cord, complete and successful. So use this information to help you with any future dial cords that you may have. The Crosley dial face is in very nice condition, and thankfully all the little chips in the paint are outside the viewing angle, so you can't see any of that with that little top window on. Now there is one that's little paint flake that's trying to come off here, and if I very gently touch it, you can see it flex. I have to be very careful with this. As you can see, it's kind of grown from this little chip here. So the best way to stop this, again, is super glue. What you want to do is at the edge, put on some super glue, and with a nitrile glove, that's what I use, is I just work the super glue around the area. You don't want to go this way because you'll chip this right off. So what you need to do is very carefully just kind of work the area, press it a few times to kind of get the super glue underneath, and then just work away at it. And that works for all of these little areas where the paint is starting to come off. It appears that the paint that they've used hasn't stuck to the metal very well at all. It almost looks like it's just sitting on top. So they should have used a better primer or something like that before they sprayed these things. But as you know, these things were pumped out probably by the hundreds of thousands. There's lots of these old radios out there like this. So that's another tip. Use a nitrile glove. You don't want to get super glue on your fingers, and this stuff's horrible to get off. At any rate, and just put a little bit of super glue on here and just work it around. Try to keep the super glue out of the viewing area, because sometimes it'll discolor the paint a little bit. So, of course, try this at your own risk and try it in an inconspicuous area first, because some paints that they've used way back when are really bizarre, and they're very, very touchy. So this one here is actually pretty good. I've tried it on a couple, and you can't even tell. But this one here is one that I've just noticed, and I'm going to have to go after that. So I'll put a bit of super glue here and then just smooth it out and let it sit, and it should be just fine. And that's how you preserve the paint on a face like this from chipping off from the edges, because that seems to be where it starts. It always starts at an edge, and then a big flake will just come right off, and you're like, ah. So be very, very careful. Always work away. Don't work towards the edge of the paint, or you'll flip that paint up and you'll have a very bad day. So I hope that tip helps you out, saving some of your radio faces. I hope you've enjoyed the tips and tricks that I've shared with you today. Coming up very soon, I'm going to share my potentiometer cleaning and lubrication method. So this is a method that I've developed over time, and it works extremely well. So well, in fact, that it almost seems to bring back potentiometers that don't even work anymore, aside from the ones with, broken carbon tracks and broken wires and things like that. But boy, does it work well. For example, that Westinghouse radio, that had incredibly bad potentiometers in it, and this method made them silent, and they feel like glass now. So it works very well, and that's coming up soon. That'll be an entire video within itself, and I'll go through a bunch of them and show you different types of potentiometers and how I go through and clean them. The new capacitor tester is being worked on right now, and I'll have some information to share with you in the next video about that, and I'm hoping by the end of this month, so the end of this month, right in that time frame, I will have a solid device that I can share. So that's very exciting for me. I've been working a long time on this, and it works very, very well. Increased sensitivity and everything. So that should be a lot of fun, and it's going to be very, very neat. I'm excited to share that with all of you. So if you've enjoyed this video, you can let me know by tapping the heart symbol just below the comment section here, and I will talk to all of you very soon. Bye for now.